All right, welcome to your 8.2 notes. So we will split these just like we did with our 8.1 notes. So I will make them matching sections. So part 1 will be sequences again, part 2 will be the series. So 8.2 is all about what are called arithmetic sequences and series. So arithmetic sequence is a sequence in which the difference of the consecutive terms is constant. So think about constant rate of change, what's happening each time. These terms are found by adding a constant value to the previous term. So we might be adding a positive number or we might be adding a negative number. So remember, if I'm adding a negative, it might look like subtraction. So if I'm subtracting by the same thing, that would be like adding a negative number. That common difference is the constant that is happening each time. So am I adding by 3 each time? Am I subtracting by 2 each time? That would be your difference. So we're going to start writing that as D. Okay, so D equals a 3, maybe it equals a negative 2, so on. Okay. So what we're going to do first is just tell whether the sequence is arithmetic or not. So I'm looking for that common difference. I'm looking for adding or subtracting. So I'm going to start with my first sequence down here and see what is happening to the numbers each time. So from -9 to -2, I'm adding 7. -2 to 5, adding 7, adding 7, and adding 7. So this time when I'm looking at it, I'm thinking, yes, the same thing is happening each time, so this is an arithmetic sequence. Okay, on the next one, remember I'm looking for what it is adding or subtracting by, so my numbers are getting smaller, so I'm thinking this one is subtracting. So I'm subtracting 8, and then 15 to 9, I subtract 6, and then subtract 4, and then subtract 2. So this one is not arithmetic because it is not constant. Okay, so this one is a no. So we're going to do a few more of those. We're making sure that we're explaining so that we understand why it is or is not. So I'm looking at my next sequence, figuring out what is happening between each of the numbers. So from 2 to 5, I'm adding 3. 5 to 8, I'm adding 3. 8 to 11, adding 3. 11 to 14, adding 3. So yes, this is arithmetic because I do have a constant difference or a common difference, and that is by a positive 3. So my D or my common difference would be 3. My next one, I'm looking at 15 to 9, that's subtraction of 6. 9 to 3, subtracting 6. And then it looks like I'm subtracting 6 all the way across. So this again is arithmetic because that common difference is a -6. So you're adding -6 each time, or what looks like subtraction. Okay, the last one of these, remember we're looking at adding or subtracting, so they're getting smaller. So I'm going to say 8 to 4 is -4. 4 to 2 is -2. And I have -1 and then -1/2. So even though most of you can recognize this as division of 2, so dividing by 2 each time, I'm looking for adding or subtraction for it to be arithmetic. So this is no, because you are not adding a constant. It's not adding or subtracting, so you're not adding a constant each time. So what we're going to look at next is actually writing the rules for these sequences. Now in 8.1, we wrote a few rules for sequences, but some of them were a little bit hard to find. And so in 8.2, we're going to be a little more specific, and we actually have a formula in order to help us out here. So when we find our rules, what we're typically going to plug in is the first term and our common difference. Okay, we don't want to plug anything in for n because that's our term number, so that's going to help us find a term number later. So it's actually like the x in the equation. We're leaving the n in there. And then this is like the y of the equation. That's our answer, so we're not going to plug anything in for that either. Okay, so we're going to write the rule for the nth term of the arithmetic sequence. So I'm looking, and I'm going to go ahead and label this as my A1. That's my 3 to start with, because I know I'm plugging that in. And then the other thing I need to find out is my D. So what's happening each time to these numbers? So from 3 to 7, 7 to 11, 11 to 15, I'm looking that this is adding 4 each time. So my common difference is going to be 4. So when we plug it into that formula that's above, we're going to plug in our 3 for our first term. We're going to leave n in there so that we can find the nth term later. And then we're going to plug in a 4 here on the end. So we don't want to forget that when we have a constant on the outside of our parentheses, this is a lot like multiplication. Okay, we're going to distribute to get a more condensed version of our rule. So we have 3 plus 4n minus 4. And then combine those like terms. So our rule looks like 4n minus 1. So we had some that looked like this in our 8.1 notes. A lot of them I drew a graph for or noticed something that was a constant rate of change. So we thought about it kind of like y equals mx plus b. So that's why our rule looks a lot like that. Okay, let's go ahead and write the rule for the nth term of these sequences, and then once we have written the rule, we're going to find the 15th term. So a sub 15, that's the 15th term. So the first thing that I'm going to do is look at these and figure out what my common difference is. So what is happening each time? And it looks like on this first one, I'm adding 5 each time. So my common difference is a 5. Remember, this is my first term, that's my A1. So when I'm plugging it into that formula, I am plugging in my A1 and my D. So I have my nth term is going to be 3 plus the quantity n minus 1 times 5. I'm going to go ahead and distribute that 5 out and simplify those like terms together, and I get 5n minus 2. Okay, and the other part that we're going to do is find the 15th term. So I'm going to take that equation that I just made, and I'm going to plug in 15 to that. So when I plug in 15, my 15th term becomes 73. So if I worked this out 15 terms later, I would have 73. Okay, next one we're going to follow the same pattern. So we are going to start by finding what that common difference is. Okay, this time it is subtracting 8 each time. I'm going to plug that into my formula. So I have, remember this is my first term. So I have 55 minus, or plus, excuse me, n minus 1. And then I have a negative 8 on the end for my difference. Okay, so when I simplify and I multiply that all together, I end up with negative 8n plus 63. And the last part that we're going to do is find that a sub 15. So our 15th term, we're going to take negative 8 times 15 and add 63 to that. And we get negative 57. Okay, the cool thing about this formula that we have now is that we can actually write the rule for a sequence only knowing one of the terms, its location, and what the common difference is. So remember, we're working with this basic formula. And what we already know is that the common difference is negative 3. And we also know that the 19th term is negative 45. So what I'm going to do is I'm going to say the 19th term is equal to our first term, because we don't know what the first term is. But we do know that we have the 19th term is what we're talking about, and our common difference is 3. And we said our 19th term is negative 45. So I'm going to go ahead and plug that in there. I'm going to simplify this to 18 times negative 3. And when I solve this and move that over to the other side, I get that my first term is 9. Okay, once you have your first term, what we're going to do now is try and write the nth rule for that. So I know that my first term is a 9. I'm plugging that back into the original formula. Plus n minus 1 times my negative 3. I'm going to multiply that out and simplify. So remember, that's going to look like something like this if you're doing it part by part. And then combine your like terms together, so you get a sub n is negative 3n plus 12. So there is my rule for the nth term. Okay, we're going to try another one of those. So the common difference this time is a negative 4. And I know that the 17th term is 2. So I'm going to plug in what I know into that original formula. So I know I have my 17th term is 2. I don't know what my first term is. I know I'm talking about the 17th term, that's your term number, and that my common difference is 4. So this time I have 2 equals that first term, which is unknown. And when I simplify all of those numbers together, I get minus 64. So I'm going to add that to the other side, so my first term is 66. Okay, once you have your first term, you can plug that back into your original formula. So I'm going to have 66 there, plus n minus 1 times a negative 4. Remember, you are distributing that negative 4 to both of those items inside the parentheses. And we have our nth rule, which is negative 4n plus 70. Okay, sometimes we are not actually given our common difference. So in this one, it says write a rule for the sequence where the 7th term is 17 and the 26th term is 93. So this one's going to take a little bit more work, but we are still using that same formula to help us out. So I'm going to go ahead and write that at the top of the page. And I know that I'm going to start with this one just because it's on the end there. My 26th term is 93. So I'm plugging in all of the pieces that I know there. Unfortunately, I don't know what that D is, but I can simplify this a little bit more. So I have 93 equals my first term plus 25D. And then I'm going to do the same thing with my other term. So I know that the 7th term is 17. I don't know what that first term is, but I can plug in that the 7th term is 17. And simplify that a little more, so I have 17 equals my first term plus 60. Okay, so what we have now are actually 2 equations that we can work with in order to solve for our first term, or our D. Okay, so looking at those two, if I put them right on top of each other, it might help us out. Okay, so I can solve this system of equations using elimination pretty easily because those first terms are both going to cancel out. So now when I subtract, I'm going to have 76 equals 19D. And when I divide by 19 on both sides, I can find my common difference is 4. So that's going to be a big help for us because now we can plug that information in order to find our first term. So let's go ahead and find our first term. So I'm going to use this right here that says my first term is 6 times 4, and that should equal 17. So this is going to help me solve for my first term. So I'm going to multiply 6 times 4, I get 24. Subtract that to the other side, and I get my first term is negative 7. Okay, and now I finally have enough information to find my final rule. So I'm going back to the original equation up here, and I'm plugging in everything I know. I have the first term is a negative 7. Remember, we want to leave the n in the equation, and we found our common difference was a 4. So I'm going to multiply those together and then combine like terms. So my rule is negative 4n minus 11. Okay, for our last example, we're going to do one more of those. So remember, you are writing an equation using each of these pieces as information. So I know that my 7th term is 71. So I'm plugging all of that in. I'm going to simplify this. So I have 71 equals my first term plus 6D. Then I'm going to do the same thing for this other term. I know my 16th term is 26. And I'm going to simplify that. 26 equals my first term plus 15D. I'm going to put those together so that I can simplify and solve for my common difference because, again, those first terms are going to cancel. So I get 45 equals a negative 9D. And so when I divide, I do end up with negative 5 as my common difference. Then the next step is to use one of the equations to solve for your first term. So I'm plugging in that common difference. I'm getting that 26 equals my first term minus 75. So my first term is 101. And the last step is to plug that into the equation. So I have 101 plus n minus 1 times my common difference of negative 5. I'm going to simplify that as much as I can. And my rule is negative 5n plus 106.